In this video, we are going to talk about derivative of inverse trigonometric functions. First, we will look at the main formulas for the derivative of inverse trigonometric functions, and then we will use it to find the derivative of the functions involving these inverse trigonometric functions. So first we have sine inverse x. Its derivative is 1 over square root 1 minus x square. Remember that here the angle of the inverse trigonometric function is x, and here you have to square this angle. Now we have y equal to cos inverse x. Its derivative is minus 1 over square root 1 minus x square. The derivative of tan inverse x is 1 over 1 plus x square. Derivative of secant inverse x is 1 over x multiplied by square root x square minus 1. Derivative of cosecant inverse x is minus 1 over x into square root x square minus 1. And the derivative of cot inverse x is minus 1 over 1 plus x square. Now let's use these formulas to find the derivative of the expressions involving these inverse trigonometric functions. First, we have to find the derivative of y is equal to sine inverse x cube, and we have to find dy by dx. We know that if the function is y equal to sine inverse x, then its derivative is 1 over square root 1 minus and the angles square. Now for the function y is equal to sine inverse x cube, its derivative by using this formula is 1 over square root 1 minus angle square. Here the angle is not x but x cube multiplied by derivative of the angle. Here angle is x cube, its derivative is 3x square. We will simplify it. So we have dy by dx is equal to 3x square over square root 1 minus x to power 6, and we are done with this question. Let's do another question. We have y is equal to secant inverse e to power x. Here the angle is not just x but e power x, and we have to find dy by dx. Now we know that if the function is secant inverse x, then its derivative is 1 over angle, which is x, square root angle square, which is x square minus 1. Now let's use this formula to find the derivative of the function y is equal to secant inverse e power x. So we have dy by dx is equal to 1 over angle. Since the angle is ex, so we will put here inside the square root angles square minus 1, and angle is e power x, so here we will put e power x multiplied by derivative of the angle. E power x derivative with respect to x is just the same, e power x. We will simplify it now. We have dy by dx is equal to this ex cancels with this ex, and we have 1 over e power 2x minus 1 square root. So we have found the derivative of secant inverse e power x. Let's do another question and find the derivative of 1 over tan inverse x. And we have to find the derivative of y with respect to x. Now see that here we have y as something by something. That is, y is in the fractional form. So we know that whenever a function is given in the fractional form and you have to find its derivative, then you can find the derivative by using the quotient rule. How does the quotient rule work? Derivative of y with respect to x is dy by dx is equal to, Now the quotient rule. Lower term as it is. Derivative of upper term here is 1, its derivative is 0, minus upper term as it is. Derivative of lower term is tan inverse x, its derivative is 1 over 1 plus x square, divided by lower term as it is and its whole square. Now simplify this. This becomes 0 minus 1 over 1 plus x square divided by whole square of tan inverse x. We can simply write it as minus 1 over 1 plus x square tan inverse x whole square. So this is the derivative of expression y equal to 1 over tan inverse x. Please know that you cannot write this expression as y is equal to tan power 1 of x. That is, you cannot bring this tan inverse x which is in denominator up, because this is the inverse trigonometric function. If there is a positive power on a trigonometric function, this can be written as the whole power, but if there is the negative power, it cannot be written as tan x to power minus 1, because this minus 1 is used for the inverse trigonometric function. So here in denominator tan inverse x, it's the inverse trigonometric function. It is not tan x to power minus 1. Let's attempt another question. We have y is equal to ln of sine inverse x, and we have to find dy by dx. So if we have ln x, its derivative is 1 over angle, that is x here. So when we find the derivative of y with respect to x here, by definition of derivative of ln x, here we have 1 over, but here we don't have x, we have sine inverse x. And then the derivative of sine inverse x, which is 1 over square root 1 minus x square. We can write it as dy by dx is equal to 1 over sine inverse x square root 1 minus x square. So we have found the derivative of ln of sine inverse x. Let's find the derivative of another expression. Y is equal to square root cot inverse x, and we have to find the derivative here. Let's rewrite this expression y as cot inverse x to whole power 1 by 2. Now to find the derivative, we can see that y is written as cot inverse x and the whole power is 1 by 2. Whenever there is the whole power on a function and we have to find its derivative, we will start applying the power rule. So power rule says bring the power on side, whatever is inside it remains as it is, and then subtract 1 from the power, and then the derivative of the inside term multiplied by derivative of the inside term, which is cot inverse x. Its derivative is minus 1 over 1 plus x square. We will simplify it. Dy by dx is equal to 1 over 2 cot inverse x to power minus 1 by 2 into minus 1 over 1 plus x square. Then we have dy by dx equal to 1 over 2 cot inverse x to power 1 by 2, and the minus sign here multiplied by 1 plus x square. So that's the derivative of the expression y, which is square root cot inverse x, and this is how we find its derivative. Let's do one more question where we have to find the derivative of y which is equal to cosecant inverse e power x plus cot inverse square root x. So we have to find here dy by dx. To find the derivative here, first term is cosecant inverse e power x. So cosecant inverse x derivative is minus 1 over x square root x square minus 1. But here angle is not x, it is e power x. So by formula it is minus 1 over angle, which is e power x square root angle square minus 1 plus cot inverse x derivative is minus 1 over 1 plus x square, but the angle is not x here, it is square root x. So we have minus 1 over 1 plus angle its whole square. Let's simplify and we shall have minus 1 over e power x square root e power 2x minus 1 over 1 plus x. So we had the function y equal to cosecant inverse e power x plus cot inverse square root x, and we have found the derivative by using the derivative of inverse trigonometric functions formulas.